now that we've seen one example, let's figure out which of those pieces correspond to which one of these steps on this big list here. So first one is to draw and label a picture. Okay. Now, we actually didn't do this in our example because there wasn't anything geometric going on. We were just asked to minimize the sum of two numbers. So we actually skipped this step, but it's going to usually be important for us because it's going to help us visualize what's going on. And in the process of making that diagram, you'll wind up labeling it. And once you label it with variables, that'll help you set up your constraint and your objective functions. Next, well, what is an objective function? Well, this is the thing that you're going to be maximizing or minimizing. So in other words, this will be the function that you're going to take its first or second derivative, or maybe both. Okay. The constraint is the function that's going to actually allow you to perform calculus on the objective function. That objective function will often have multiple independent variables. The constraint equation will allow you to reduce it to one independent variable so that you can take your first and second derivatives. Okay. And constraints pop up pretty naturally. Okay. We might be thinking about minimizing the surface area of the packaging for something that we want to ship. And the constraint might be, well, this thing needs to be able to hold let's say 10 cubic inches of volume. Okay. So it has to hold at least 10 cubic inches of volume, but we want to minimize the surface area of this so that when we ship it, maybe it costs less. Okay, that's kind of the idea here. Or maybe it costs less to make. So that's what an objective or a constraint function is. The next thing is that function that we want to maximize or minimize, we want to find its domain. Okay. And this is really important because what we're going to see here in a minute is depending on whether that domain is an open interval or a closed interval will determine what we're going to do next. Okay. In step 6. Okay. Step 5 will be the same no matter what. You want to find those critical points. Now, if you have a closed interval, use the closed interval test. The closed interval test is perfect, right, for finding absolute maximums and minimums. But if this is an open interval, we're going to have to use a modification of the first derivative test or the second derivative test. Okay. And what will happen if we're in the second case where we have an open interval is on that domain you're looking at, you'll actually only end up with a single critical point. Just like we actually had happen down here, right? We were able to say that, hey, the only critical point was x equals 10. And when this happens, if you only have one critical point, then if you can show that, let's say we're talking about a maximum here, by the way. So say some max. If this is the only critical point, if you can show that the function is increasing everywhere to the left of this point, and then show that it's decreasing everywhere to the right of this point, then you know that that critical number is associated with a absolute maximum. Not just local, but absolute maximum. And if we want to think about the second derivative, if you can show that it's concave, let me see here. If you can show that it's concave down everywhere on its domain, again, concave down everywhere on its domain, then you know that this one critical number you have must be an absolute maximum. Okay. And so that's the idea that we're going to be using here. We're either going to have a closed interval, and we can use a closed interval test, or we'll end up with a single critical point and the function's concavity isn't going to change over the interval, so you'll be able to determine that you have a absolute maximum or minimum. Okay. Let's see, is there anything else I want to say about this? Yes, so even though all our problems are going to fall into these really two simple cases, it is possible, right, that we have multiple critical points in an open interval. And then the question would be, what are you going to do from there? Okay. Well, if we did have multiple critical points in an open interval, then we can't use this technique anymore. It's what we're going to have to do then at that point is maybe rely on using a graphical interpretation of the problem. We might instead maybe use technology to help us find those maximums or minimums.